Okay, we're back. Okay, and we're looking at this annuity derivation. We went through uh, our oversimplified model uh, at contributing $1,000 a year at the end of every year, at 10% for 6 years, and saw that we accrued $1,715 in interest. Okay, so we took this formula that was uh, the formula for summing terms of a geometric series, and we modified it to a more realistic issue for our annuity. Just we changed up some variables, okay, just by naming them. The variable here, sub n, is now sub t because it's not is it n was the number of terms, which is synonymous with the number of years. We had to modify the rate, okay. The R value up here was a constant ratio, but that incorporated 1 plus the rate R. Unfortunately, we used the same variable, but that's sorry about that, but that's just what happened. Okay, so we had this, we put that in, then we tailored things to come down to this formula, which I know looks a little awkward, okay, because the 12's there, because we're making our contributions on a monthly basis, okay, and we're just going to streamline that and work with that from here. So here it is again. We have this, but we're just going to streamline this. We're going to call I the value of R over 12. So then it just looks a little bit more user-friendly here, where we replace I with the value R over 12, and we get this equation here. So this is a more manageable equation, okay? And we're going to use that in the following example. C, of course, is the monthly contribution. So here we go. We're going to say that you are going to make a $100 contribution per month in an annuity that's paying 5% for 30 years. So we want to see what is going to be what's called the future value. What will you have invested after a 30-year period here? Okay. Again, oversimplified to the extent that no one will guarantee you 5% for that duration of time, but here we go in anyway. Okay. So there's our equation. First thing we got to do is determine I. I is R over 12. So we've got our 0.05 divided by 12. That's this decimal value. You want to carry all those decimals. Don't want to lose those. Okay. And then we're going to put everything else into this formula here. Okay. So C is the monthly contribution. We put everything in. We're going for 30 years. So we're up with 83,219. So what did you actually make in interest? Well, honestly, you made more in interest than you contributed, because you only contributed $100 a month for 30 years, and 30 years at 12 months per year is 360 months. So you contributed $36,000, but you made $83,000. So obviously you've made $47,000 in interest. Not bad. Okay, that's why it's an investment. All right. So of course, you invest more at a higher rate, you're going to do better. Of course, all that you've earned in interest is subject to taxes, so you have to learn to play that game as well. But at any rate, that's what you have, okay? And that's a realistic value. Uh, Only unrealistic thing is that guaranteed rate of 5% for 30 years. So um, that's a little unrealistic, but so it goes, okay? Um, so uh, we said here that this is our formula, but this formula should be able to be manipulated in any which way. So we're going to take a look at that and in the next problem. And you should think about and I'll go over this in another video, putting a calculator program together for this, because it is a really useful thing to have for the problems you're going to have, as well as for future reference. Okay, so let's look at another problem. Okay, again, here's your working formula. Remember that. Okay, we're gonna tweak this out a little bit and manipulate this formula to this problem. So looking down the line, you're looking at wanting to have $500,000 for retirement, and you're going to save so much per month. That's the question. How much do you have to save per month if after 40 years you are going to have $500,000 and you anticipate that you can get 8.5% interest? Again, that's idealistic. Of course, most investors will tell you you're doing well if overall, through whatever investments you have, combinations of investments, you're earning. If you're earning that rate, 8.5%, you're doing pretty good. Most people try to shoot for 10. At any rate, this is the parameters of our problem. Again, trying to earn $500,000 by monthly contributions, as yet to be determined, uh, at a 8.5% rate for 40 years. So again, here's our equation. What do we have? What are we looking for? Well, what we're looking for is C. That's the monthly contributions. That's what we don't know. Everything else we do know. Okay, we know that the sum total, S sub T, wants to be $500,000. We know we've got a 40-year period. Our I value is our rate divided by 12, so that's the 0.085 divided by 12, so that's this decimal value. Again, take all those decimal values, don't throw them away, all right? And we'll just put everything in and do the number crunching. So here we go, okay? I'm going to just work with this bracketed item here first, throwing in the values, okay? Doing the number crunching. All right, here it is. You can run that through for yourself on your calculator. Should not be that difficult, okay? And we come down to this. So basically, now that whole bracketed item is 4,038 and 0.65, okay? So that's what we got. And simple problem from there, just divide through and determine the monthly contribution. So there you have it. Less than 125 a month, $123.80 per month. If invested for 40 years at 8.5% in an annuity, will return to you $500,000. Not bad, not bad. Okay, what did you actually contribute? Wow, this is what you did. You put 123 a month for 480 months. That's 12 times 40. That's 59,000. 59,000 turned into 500,000 inside of 40 years. There's your retirement. There's your nest egg, okay? All right? Invest wisely. Do well, my friends, okay? There you have it. We're going to, I don't know, I think we'll stop it at this point, and because the next one is going to be this, the reverse annuity, otherwise known as a mortgage. So we will tend to look at that in the next video. Okay? All right.